Good morning. And if you are one of the few people who watched my last video about drawing with epicycles, welcome back. This time, I'm tackling space filling curves, or more specifically, the Hilbert curve, as you may have guessed from these wonderful images, which I'm going to program. It's worth mentioning that none of these are actually the Hilbert curve. The Hilbert curve is what you get when you repeat this process infinitely many times. So what this is a sequence, and you start with this. And to get the next term in the sequence, you take 4 copies, one in each corner, and rotate the bottom 2 a bit and connect up the edges. The cool thing is, if you repeat this infinitely many times, you get a line which covers every point in 2D space. Think about that. Something one-dimensional filling every point in 2 dimensions. And in real life, we can only do a finite number of iterations. But you'll see, as there are only a finite number of pixels in the screen, after so many stages, it really does appear to fill 2D space. So to program this, I created a new sketch in processing, and I start with setting the frame rate, window size, pen color, and pen thickness. And you'll notice these are powers of 2. That's just so on the last step, when everything fills the screen, all the edges line up nicely. And this here is just to slow down the program so it doesn't rush through every step without you being able to see it. So I add to my curve the 4 points, left, top right, and bottom right. And down here in draw, I just loop through all the points in my curve and draw a line connecting them. So if I run it now, you'll see we'll get the first curve. And so all we need to do now is write a function which takes one curve and produces the next in the sequence. So here it is, and what I'm doing here is setting up a new array and copying the old array into it, but half as big, and modified by a certain amount depending on what corner it's in. Then at the end, I just set curve equal to the new curve. And taking a closer look at how we create the next step, we see that we add the points from the bottom left first, then the top left, top right, and bottom right. So in the bottom left, we want to rotate it. Remember, we want to rotate it clockwise. And to do that, we need to switch the x and the y coordinate. So I've got the old y coordinates in the new x, and the old x in the new y. And they're both negated because it's clockwise and not anti-clockwise. And these width divided by 2 and height are added just to position it in the bottom left where we want it. Next is top left, and that's simple enough. It's just the old curve but scaled down by half. And the top right similar, we just shift it to the right. And finally, the bottom right is again similar to the bottom left. We switch x and y, but this time they're positive as we're doing an anti-clockwise rotation. I then call it in draw, and it should be ready to run. Hopefully there aren't any errors. And there's the first curve. And the second. I think it's working. Surprisingly, there aren't any errors. And there you go, the sequence of curves that lead to the Hilbert curve. If you program this, by the way, there are other space filling curves to try. One, I think the first discovered was the piano curve. And you might point out this isn't filling the whole plane, it's just filling a square. But you can just tile the square to get the rest of the plane. And look, it's almost filled every point, or at least each pixel in the window. It's quite slow. There are probably too many points in the array. Not much longer, hopefully. There, it filled the window. A 1D line filling 2D space. And actually there's one last thing I want to add, which is save frame into draw. And what that'll do is it'll save a picture of the Hilbert curve each step, and when it saves it, it'll replace these hashtags with a number. And that's everything. Thank you for watching. Don't forget to make this yourself. And I hope you enjoyed, and I'll see you again soon.